The dark matter enigma. Illusion or reality? Look at the starry sky. Billions of galaxies, stars and planets populate the vast cosmic expanse. Majestic spirals of light, gas and dust, each home to billions of suns. Yet what we see is only a tiny part of reality. Imagine for a moment, 85% of the universe's mass escapes us, hidden in the shadows, an invisible, intangible substance that neither reflects nor emits any light. Scientists call it dark matter. Welcome to X Theory. Today, we dive into the heart of a fascinating cosmic mystery, the enigma of dark matter. Our story begins in the 1930s with a Swiss astronomer named Fritz Zwicky, a brilliant mind, perhaps a little eccentric, but with extraordinary intuition. Zwicky was observing the movement of galaxies within the Coma cluster, a gigantic grouping of hundreds of galaxies. He expected that the galaxies, bound together by gravitational force, would move at predictable speeds. However, what he observed defied the known laws of physics. The galaxies were moving much faster than expected, as if an invisible force was pushing them. Zwicky then made a bold hypothesis. What if a form of invisible matter, present in much larger quantities than visible matter, was responsible for this gravitational anomaly? He named this mysterious substance Dunkel Materie, dark matter. At the time, the idea was revolutionary, almost heretical. Decades later, other astronomers like Vera Rubin confirmed Zwicky's observations. But if it was real, what was it made of? And how could we detect it? Since the pioneering observations of Zwicky and Rubin, dark matter has become one of the biggest mysteries in modern astrophysics. We know that it represents about 85% of the total mass of the universe, and that it plays a crucial role in the formation of cosmic structures. Yet, despite decades of intensive research, dark matter remains an enigma. It emits no light, reflects no radiation, and interacts with ordinary matter only through gravity. Scientists have proposed many theories to explain the nature of dark matter. One of the most popular suggests that it is made up of weakly interacting massive particles, the famous WIMPs. Other theories evoke the existence of axions, ultralight particles with strange properties, or even primordial black holes. Each hypothesis has its strengths and weaknesses, but none has yet managed to convince the entire scientific community. What if the solution to this mystery lies not in a new exotic particle, but in a re-examination of our fundamental theories? Imagine for a moment that dark matter as we conceive it doesn't exist. What if this invisible force that seems to govern the universe is not due to a mysterious substance, but to a gap in our understanding of gravity itself? This is the bold hypothesis proposed by some alternative theories like Mond theory for modified Newtonian dynamics. According to this theory, gravity would not behave exactly as predicted by Newton's theory of universal gravitation, or even Einstein's general relativity, on a very large scale. Imagine an apple falling from a tree. Newton taught us that this fall is due to the force of gravity exerted by the Earth on the apple. But what would happen if, at astronomical distances, this gravitational force started to act differently? That's what Mond theory proposes. It postulates that the force of gravity would be more intense at low acceleration, which would explain the rotation speed of galaxies and galaxy clusters without the need for dark matter. So, is dark matter a physical reality, an exotic substance that still escapes our understanding, or is it a mirage, an illusion created by our incomplete knowledge of gravity? For decades, scientists around the world have been competing in ingenuity to try to detect dark matter. If it is made up of particles, however elusive they may be, there must be a way to observe them, to capture their fleeting signature. Imagine underground laboratories, buried miles beneath the Earth's surface, sheltered from cosmic rays and any other interference. Ultra-sensitive detectors, cooled to temperatures close to absolute zero, scrutinizing the slightest sign of interaction. It is in these extreme conditions that the hunt for dark matter takes place. Experiments like Xenon, Lux, or Pandax use cutting-edge technologies to try to detect collisions between dark matter particles and ordinary matter. These collisions, if they occur, are extremely rare and difficult to distinguish from background noise. So far, none of these experiments has been able to directly detect dark matter. Some see it as a sign that dark matter is just an illusion, while others persist in believing that we are about to unravel this mystery. The quest for dark matter is a thrilling scientific adventure, pushing the limits of our knowledge and technology. A bewildering alternative. What if gravity itself was wrong? Let's question one of the fundamental forces of the universe, gravity. What if, instead of imagining a new form of invisible matter, we reconsider our very understanding of this force that governs the cosmos? Since Newton and his apple, we think we know gravity. It keeps our feet on Earth, guides the planets around the sun, and shapes the structure of the universe. But what if this force at cosmic scales behaved differently than we thought? This is the bold hypothesis of Mond theory, modified Newtonian dynamics. According to this theory, gravity would not act linearly. At low accelerations like those observed at the periphery of galaxies, the gravitational force would be more intense than Newtonian physics predicts. Imagine a magnet whose attractive force increases as you move it away. Counterintuitive? Certainly. But this is precisely what Mond proposes to explain the behavior of galaxies without resorting to dark matter. If Mond were correct, it would mean that our understanding of gravity is incomplete. And what do you think of this enigma, dear explorers of the cosmos? Is dark matter a tangible reality or an illusion created by our ignorance? Share your thoughts, questions, and theories in the comments below. Don't forget to subscribe to X Theory so you don't miss any of our scientific explorations. Together, let's continue to explore the mysteries of the universe, nurture our curiosity, and push the boundaries of knowledge. So, stay curious, keep an open mind, and never forget to look up at the stars.